Alright, this is Austin Eldridge. Today we're going to be looking at the basic creature simulation. One day I hope for it to be a neural net and we can do some evolution simulations with this and things like that. But just to go through this code step by step to help people understand what's going on, there's comments throughout the code that should teach you just about everything that's been put into it. But just to start, we have a standard libraries. Time.h is to help with the random number generator. It takes your computer's time and creates a random number using that. These are our currently declared functions. They're all defined down below the main function, but they're defined up above so that when they're called, they're not throwing an error. For now, this code is made to spawn in the entities, give them random traits using a 3-digit number, and then a random location on a grid that's not yet implemented that is using any number in the thousands from 0 to 9,999. So to start out, srand is the function that makes random or like chooses a random number. I think it's between like 37,000. But I use modulus in order to form the number that I want between a certain area. To start, we're going to be making a settings list that holds the desired settings for the simulation. This is 3 items long, 0, 1, and 2, and then our setup function will immediately be called, and this will take user input, and then set that user input into these setting locations in this list so that we can access them later. The user input that's available is the number of entities you'd like to generate. Right now I have it saying up to 20 just because the code's not perfect, but I could put 9,000 in here if I wanted to and it wouldn't make any difference. Of course, that would make your computer do a lot of work. The next one is the amount of generations you'd like to perform. So the way this simulation will work is the entities will be asked to go to a certain location on the grid, and if they're not able to make it by the number of steps in a generation, they will not be able to reproduce. And the ones that do make it to that corner will reproduce. And so it will be like an evolution simulation in the fact that only the ones that are smart enough to make it to that corner will move on. And then please enter the amount of actions that you'd like each generation to have. So these are called steps as well. But this is each generation you have, say, an input neuron and an output neuron. And your input neuron, if it fires, if the criteria matches, it will say, for example, the output would be move up 1 if there's like a creature within 10 spaces of you. And so if it was able to move up 1 and the reproduction cycle was at the top of the grid and we had 20 steps and that was enough steps for it to move to the top of the grid, then it would reproduce. So that's what the steps per generation is, and the generations are the amount of generations total that you'd like to perform before ending the simulation. So there's that. We have an entities list that will be holding the data for the entities. This could be done, and you can see up here in some commented out code, as a class or as objects. Each entity could be its own object and hold different attributes. For right now, they're not complex enough, I feel, to need a lot of attributes. I can describe all the trait and the output trait and whether it's alive or dead in a simple 3-digit number from 1 to 999. Well, I guess it would be 100 to 999 because each number will represent one thing. So just to show you that, we haven't gotten to that point in the code yet, but here's the user input. And here is our traits. So you see entity 0 through 19, which is 20 different entities. They have these traits. So this is the input trait right here. So input 3 trait out of 10. Output trait 6 out of 10. And 0 shows that it's still living. So through the simulation, if it dies for some reason or the other, or it's killed by somebody else's output trait, then that number would become 1. It's just like a Boolean. And then so there's that. Our entities list. We have a create entities function that simply uses random numbers by the modulus of 10, and then we'll multiply them to the degree that I want them, or the position that I want them in the number between 100 and 999. So this is just random numbers. This is just random numbers. The input trait is multiplied by 100 to show the hundreds place, like this 3. The output trait is multiplied by 10 to show the tens place, which is like this 8. And then I have while loops in here so that if we don't want to end up with the random number being 0 and the number being something like 80 instead of 380, because that's not intended. It'll break the system. Our traits here, essentially it'll add it to a list, and that list will be however many entities we have to check for later on in our program. Our generation is equal to 0 right now, because we're just starting the simulation. The list size will be inputted into the locations so that our locations match the amount of entities that we have. So if we lose entities, that list size will still be able to match later on when we run through through its locations. This is just a simple while loop that's going to act as each generation essentially. And in each generation, we're going to currently place the entities on a grid between 0 and 9,999. Each place will have one value, and that's where the thing will be placed. And then I break this loop just so that I can print out and show you these entity locations down here. Because otherwise, since these entity locations are randomized each turn, and so that will make it so that I'm not printing, the amount of entities times the amount of oh, I have it written right here. Yeah, the generation times the location times the entities amount of times. I just want to print you one set so you can see what it looks like. And then this is a simple for loop that will eventually hold most of the nested functions for taking steps for input and output neurons. Currently, I don't have any input or output traits added yet. Once I get those, I'm sure the simulation will be much more interesting. And then, of course, each time that we go through that loop, we're going to be adding a generation. So if we have 20 generations, this loop will go through 20 times and will respawn these entities or reproduce these entities and find the one that we want, or the one that's most suited for living in the environment that we give it. And that's my code. It's still a work in progress, but it shows quite a bit of what I've learned for learning C++. It's a really intuitive language. It is a lot pickier than the Python that I'm used to, but I've enjoyed learning it a ton. So thanks for watching.